Good afternoon. My name is Nicholas Bramhall, and this is my lab report for Lab 5, and we got a really simple one for you guys. So, the point of this lab is to understand how collisions work and to predict how the energy and speed of these objects change before and after collisions. This is a very simple experiment. We just have two crash carts, where the crash carts are the systems, and everything else is the surroundings. Alright, so what are we doing? First of all, we're making predictions, which we'll go over in the next slide. And then we're going to take a cart, we're going to roll it towards another that's stationary, we're going to record the collision, and then we analyze that collision in Tracker, focusing around the time of the collision, and then we draw conclusions from that and see if we match the prediction. So our prediction is that the cart speed will drop around by half and we'll lose significant energy, and this is due to these equations right here, and that we can see that this right here, m1 plus times v1 plus m2 times v2 is the total potential momentum, and then when we divide the total momentum by the total mass, we will get the total velocity. Granted that this is 0 and this has that, we will understand that the total divided by, the 1 divided by the total will get us v final, and seeing how total is just double of m1, we can understand that v final will have to be half of v1. And of that, furthermore, we can understand that we can see here that any change in velocity is squared. So we're predicting a significant change in the change in energy due to the fact that velocity matters immensely in kinetic energy. Now, here we have our delightful demo.
He's
Let us watch
downgrading
it.
my lab to like the last week.
Okay, it's got sound. Let's turn that off. Boom. It's moving. What?
He's downgrading
So
my
we got
lab to
car right
like the
here,
last
moving,
week.
boom, crashes into the stationary object, it goes. Beautiful.
He's
Alright.
downgrading my lab.
So, we got some graphs here. I love graphs. We got this one right here, cart stationary until right here. This is about the collision. Now, there is no substantial change in this graph, but obviously there's a big one here. And we can see here in the data tables, it's currently averaging around here 76 centimeters per second. And then after the fact, it's now averaging around 45 centimeters per second, which is a huge drastic drop. And then over here, we can see that obviously 0 before, and then it's averaging around 32.55 centimeters per second. But when we combine them together, the averages of A and B, we get 38.5 because it's one system. Alright, now we got the calculations using the data from the graphs and the tracker in the previous slide. We got the initial velocity of 0.76 times the initial masses, which, they don't change. The masses of the carts are about 500 grams. So it's simply 0.5 times 0.76, and we get 0.78. And now 0.78 divided by the total mass, which would be 1 kilogram, it's 0.38, which is approximately half, which is as we predicted. And it actually matches the combined average mentioned just previously. Now taking that initial velocity, we can plug it into the kinetic energy formula. We get 0.1444 joules, and then we plug in the velocity after into the next, and we get 0.0722. And we see here kinetic energy only decreased by around half, which is a lot less than I was expecting before. But we continue. Alright, so with this in mind, what does it mean? So this is considered a maximally inelastic collision, but how do we know that? And the way we know is because that when we crashed them together, they stuck together, and there was a change in kinetic energy, which tells us it was inelastic, and the maximally comes from the fact that they stuck together. But now the reason why that was is because the cards had Velcro, so it's a little cheating. But now what if the cards didn't have a Velcro? Would they still stuck together? Would have been an elastic collision? And the cards most likely wouldn't have stuck together. Instead of cart A would have had a bigger initial velocity after the collision, while the other one would have rebounded backwards. But there still would have been a change in kinetic energy, as perfectly elastic collisions are very rare, almost impossible in real life. So now let's take some final takeaways. So the calculations given the base data are very accurate in terms of average velocity when given the initial velocity, as shown in our calculations. And the total change in energy was about half, matches our prediction. But the change in energy was a mere drop in half, which is not as severe as we initially anticipated. Now, some possible sources of errors in this experiment is inaccurate tracker data, in terms of marking the objects as they're moving. The cards are not very small, so it's easy to overcompensate and mess up tracking. And then another thing could be a lack of accounting for like other forces like friction. And now this could be counteracted with smaller delta t, giving the forces less time to enact, but then the inaccurate tracker data would become more pronounced, and it's like you gotta pick one. But that's about it. Thank you for your time. Thank you for sitting through this. Hope you have a good day.